Hi dear students. In last session we saw calculations involving unit cell dimensions. In this session, we will see imperfections or defects in solids. The real naturally occurring crystalline substances do not have perfect crystalline structures. Irregularities in the arrangement of constituent particles of solid crystal are called imperfections or defects. Defects are created during the process of crystallization, and they depends on rate of crystallization. Defects are more if crystallization occurs at fast rate. That is, defects are directly proportional to rate of crystallization. There are two main types of defects: point defects and line defects. In this chapter, we will discuss only point defects. Point defects are of three types: stoichiometric defects, impurity defects, and non-stoichiometric defects. Stoichiometric defects are further divided into four types, that is, vacancy defect, interstitial defect, Frenkel defect, and Schottky defect. Non-stoichiometric defects are further divided into two types, metal excess defect and metal deficiency defect. Metal excess defects occurs due to two reasons, that is, due to anionic vacancies and due to presence of extra cations at interstitial sites. We will learn these defects one by one in detail. So let's start with stoichiometric defects. First is vacancy defect. When some of the lattice sites are vacant, the crystal is said to have vacancy defect. This defect decreases the density of the substance. This defect can also develop when a substance is heated. Second is interstitial defect. When some constituent particles occupy an interstitial site, the crystal is said to have interstitial defect. This defect increases the density of the substance. Third is Frenkel defect. In ionic solids, the smaller ion, usually cation, is dislocated from its normal site to an interstitial site. So Frenkel defect is also called dislocation defect. It creates a vacancy defect at its original site and an interstitial defect at its new location. It does not change the density of the solid. Frenkel defect is shown by ionic substance, in which there is a large difference in the size of ions, for example, ZnS, AgCl, etc. Fourth is Schottky defect. It is basically a vacancy defect in ionic solids. In order to maintain electrical neutrality, the number of missing cations and anions are equal in this defect. Like simple vacancy defect, Schottky defect also decreases the density of the substance. For example, NaCl, KCl, etc. Second type of point defect is impurity defect. This defect arises when foreign particle present in the crystal. For example, if molten NaCl containing a little amount of SrCl2 is crystallized, some of the sites of Na plus ions are occupied by Sr2 plus. Each Sr2 plus replaces two Na plus ions. It occupies the site of one ion, and the other site remains vacant. Third type of point defect is non-stoichiometric defect. First we will see metal excess defect due to anionic vacancies. When crystals of NaCl are heated in an atmosphere of sodium vapor, the sodium atoms are deposited on the surface of the crystal. The Cl- ions diffuse to the surface of the crystal and combine with Na atoms to give NaCl. This happens by loss of electron by sodium atoms to form Na plus ions. The released electrons diffuse into the crystal and occupy anionic sites. As a result, the crystal now has an excess of sodium. The anionic sites occupied by unpaired electrons are called F centers. They impart yellow color to the crystals of NaCl. The color results by excitation of these electrons, when they absorb energy from the visible light falling on the crystals. Now we will see metal excess defect due to presence of extra cations at interstitial sites. To understand this, see this reaction. Zinc oxide on heating loses oxygen, and the excess Zn2 plus ions move to interstitial sites, and the electrons also occupy interstitial sites. Second type of non-stoichiometric defects is metal deficiency defect. This type of defect occurs due to missing of cation from one location and presence of cation with higher charge at other location. With this, we came at the end of session. In next session we will learn electrical properties of solids. If you like this video, please give a thumbs up and share it with your friends, and do subscribe our channel, and don't forget to click on the bell icon.